So, dear students, let us come to our second class, the dimensional analysis. So, first we should learn that what should be our objective behind the study of the dimensional analysis. So, the objectives are number 1, determination of dimensions of a physical quantity in terms of fundamental dimensions such as mass, length, time, quantity of substance mole, the luminous intensity in candela, etc. So, our first objective should be that. The second one, to have a flavor of dimensional analysis, and its ability to check the validity of an equation, particular physical phenomena, the validity of an equation representing a particular physical phenomena, phenomenon. Okay. Our third objective should be to reduce the complexity of a physical problem through reduction in number of relevant variables. What does it mean? It means that, let us suppose a physical phenomena is being governed by, let us suppose, 5 factors. So, if you would like to model that physical phenomena, that how this physical phenomena behaves in different circumstances, then you have to have the ideas about the relevant variables associated with that physical phenomena and effect of those variables separately on that physical phenomena. So, in order to do so, you have to vary every variable and you have to observe the effect of that variable on that particular phenomena, and later on we will compile all the data in order to arrive at a certain equation, a mathematical equation which stands responsible for the explaining that particular phenomena. So, in that case you can model a physical phenomena. Now, if you are knowing the concept of dimensional analysis, let us suppose there are 5 variables associated with that physical problem, if you do the dimensional analysis, then the problem, the total number of relevant variables may be reduced from 5 to 3, 5 to 2, 5 to 1, even in this many cases. So, if the number of relevant variable reduces, it means your time will be saved through a larger margin. That means you will not require the study of all the variables, rather you will study the only one variable and to see the effects on of that particular variable on the physical phenomena, and you can easily model the physical phenomena. So, these are the some objectives of the dimensional analysis. The second question which arises, that what this dimensional analysis is. So, second is, what is this dimensional analysis? We will try to understand by taking an example here in this case. So, the second question is, what is dimensional analysis? What is dimensional analysis? So, the answer is, it is a way to simplify problem by applying the principle of dimensional homogeneity, applying the principle of dimensional homogeneity. Okay. How this fact can be established through an example? Let us take an example. I am citing an example here. The drag force F on a long smooth cylinder is a function of air speed v. This is an important aeronautical design. When an aeroplane takes off in the air, the force exerted on this wing is the drag force. So, if you increase the velocity of the plane on a plane surface, and if you are designing the aeroplane in such a manner that the distance travelled through the bottom and distance travelled through the top of the aerofoil, if that differs through a margin, then it gives rise. This difference in the pressure creates a lift to take off the aeroplane in the air. This is the concept. This example is basically a part of that design. So, the drag force F on a long smooth cylinder is a function of air speed v, first variable, the density of air rho, diameter of cylinder d, and viscosity mu. That means you can say that f is varies as v rho d mu, or you can say v raised to the power a, rho raised to the power b, d raised to the power c, mu raised to the power d, small d. That variation may happen function. So this f is equal to a constant c d, that is called the drag coefficient. This is called your drag coefficient into v raised to the power a, rho raised to the power b, capital D raised to the power c, and viscosity raised to the power small d. So what are the factors? What are the number of factors relevant here? 1, 2, 3, 4, 5. 5 variables are there. It means, what does it mean? It means it is required the variation of CD, that is drag coefficient, because this is the proportionality factor which is working here, and the variation of this proportionality factor can decide this physical phenomena. So it is required to study the variation of CD, that is the drag coefficient. Now the drag coefficient will vary if you are varying the V simply, if you are varying rho separately, varying the D separately, varying the mu separately. In many circumstances, you can take 2 parameters at a time, taking V and D at the same time, or taking rho and D at the same time. You can take the rho D mu at the same time, V D rho at the same time. So, as a matter of fact, when you have to study the variation of CD with respect to all the aforesaid variables, so it is required that you have to go through the manifold study, and through the graphical analysis you can easily decide the exact nature of variation of CD with respect to a particular variable. The variable may be this that I have said earlier. So, study the variation of CD, that is the drag coefficient. This method requires a lot of graphical studies, lot of the study process cumbersome a little bit. The second way is apply this problem to the dimensional analysis. If you go on through the dimensional analysis, on the contrary, through the dimensional analysis, on the contrary, by the virtue of dimensional analysis, it can be deduced that CD, that is the drag coefficient, is governed by a relationship as you will find through the dimensional analysis. You can easily see that is governed by a relationship as that the CD is a function of rho dV by mu. This is the thing which you can arrive by applying the principles of dimensional analysis. Now you can see the nature of this number, this quantity rho dV by mu. It is interesting now. The quantity rho dV by mu, take the dimension of this quantity, you will get an interesting thing. Dimension of rho, that is the dimension of density, mass per unit volume, that is ml raised to the power minus 3. Quantity of d, that is the diameter, that is the length dimension, L. Velocity, Lt raised to the power minus 1, divided by mu, the coefficient of viscosity, that will be equal to ml raised to the power minus 1, T raised to the power minus 1. Cancel. L minus 3 minus 2, this will get cancelled, that is no dimension. It means through the dimensional analysis, without going into all those graphical studies which are required in order to establish the exact variation of CD with respect to the different associated variables or relevant variables, by the virtue of dimensional analysis you can easily establish that CD is a function of a non-dimensional number. This non-dimensional number rho dV by mu is not a dimensionless number. It is defined as ratio of inertial force divided by viscous force, and this quantity is called Reynolds number. So, by the virtue of the dimensional analysis, we can easily establish that CD is nothing but it is a function of a non-dimensional number, Reynolds number, which is nothing but this is the ratio of two quantities similar in nature. That is why it is dimensionless. That is the inertial force divided by viscous force. Now, so what another thing we are observing? Another thing which are observing is another thing which can be concluded from here is the number of relevant variables which are initially 5. So, secondly, dimensional analysis enables us to reduce the number of relevant variables from 5 to how much? To CD and Reynolds number. So, one of the most prominent application of the dimensional analysis is use the number of the relevant variables affecting a physical phenomena. Now come to the utility of this dimensional analysis. Let us come to the utility of this dimensional analysis. Utilities of dimensional analysis. Number 1, presentation and interpretation. Presentation and interpretation of experimental results. Experimental results. This is first utility of dimensional analysis. Second utility is those problems can be attacked. Attack, it doesn't mean that through the pistol or rifle, but attack means what necessary measures should be taken in order to solve that particular problem. So those problems can be attacked which are not amenable to a direct physical solution or theoretical solution, a direct theoretical solution. Okay. The third one is the validity of equation can be checked validity of the equation can be checked. Let us elaborate this term. I have written sometimes ago one equation that H is equal to P upon rho g plus V square by 2g plus z. This is the representation of the Bernoulli equation. The total head, that is equal to pressure head plus velocity head plus gravity head. Pressure head, kinetic energy head and potential energy head. This equation can be validated only and only if all the additive terms involved in this equation must have the same dimension, failing to which an equation can never be validated. So let us suppose you have to validate this equation, then H, the dimension of H is equal to how much? That is the L. Simply P by rho g, that is the pressure, P is the pressure. So M, L, force are divided by area, this is L square. Dimension of rho is ml raised to the power minus 3, g lt to the power minus 2. Okay. So this comes as m ml to the power minus 1, ml to the power minus 1, t to the power minus 2 divided by m l to the power minus 2, t raised to the power minus 2. This will get cancelled out. So these are the dimension L, same LL. V square by 2g, what should be the dimension of this quantity? V square by 2g, that is the LT raised to the power minus 1 square divided by LT to the power minus 2, that is L square T to the power minus 2 divided by LT to the power minus 2, that is equal to L, same dimension. And Z, that is height from the data line, that has also the dimension L. So all these quantities have the dimension of L. So the validity of the equation can be checked. Very fundamental equation of kinematics is S is equal to 2t plus half at square. At those places also the validity of the equation can be checked. The Stokes law, F is equal to 6 pi mu R into V, that can be also checked. And the number 4 is the relative importance or importances of variables in a physical phenomenon can be decided. The relative importance, a coefficient, the relative importance of V, D, mu, rho, all can be established that in a collective manner all those relevant variables stands for a single quantity, that is called the Reynolds number. So the relative importance of the variables in a physical phenomenon can be decided. And the last one, physical modeling for a process can be executed. This is also a part of this dimensional analysis. Now I would like to emphasize that what is the meaning of this dimensional homogeneity. That is the term which I have arrived so many times, dimensional homogeneity. So let us define what the dimensional homogeneity is. After that we will go through the Buckingham Pie Theorem in the present class, and after that this class will be concluded for the present day. So meaning of dimensional homogeneity is that all the additive terms in a physical equation must have the same dimension. This is the meaning of dimensional homogeneity. Important thing it is dimensional homogeneity principle is that all the additive terms in a valid physical equation must have the same dimension. This is the meaning of the dimensional homogeneity. So now let us come to the Buckingham Pie Theorem today. come to the last topic of today's class, that is the Buckingham Pie Theorem. I am writing the statement of this Buckingham Pie Theorem. You should remember this Buckingham Pie Theorem in a clear cut manner and try to understand this Buckingham Pie Theorem. I will give you some example to have a better in order to have a better insight of this Buckingham Pie Theorem in coming classes. So, Buckingham Pie Theorem. This theorem is regarded as procedure for executing dimensional analysis. Okay, dimensional analysis. The statement is, the statements are, this statement can be divided into two parts. Number A, if a physical problem involves n relevant dimensions, and m fundamental dimensions, here it is necessary to emphasize what the fundamental dimensions are. As I have told you, the fundamental dimensions here is the mass, length, time, quantity of substance, that is the mole, quantity of substance which is measured in the mole, the luminous power, electric current, that is measured in the terms of ampere, electric current, luminous intensity, candela. These are the quantities which are regarded as the fundamental dimension. You can easily see here the physical concept of the fundamental dimension is, if you combine these quantity or these dimensions, in no way you will arrive at a dimensionless number. You cannot derive dimensionless number or dimensionless group from these dimensions. That is why these are called the fundamental dimensions. So, if a physical problem involves n relevant dimensions, that is the parameters which involves a physical phenomena, and the m fundamental dimensions are there, then the number of pi groups or dimensionless groups which can be framed for the present problem that is equal to n minus m. So, the n minus m is the number of the dimensionless group or pi groups which can be generated through this situation. That means, if the n number of relevant dimensions are there and which in turn gives rise to the m fundamental dimension, then the n minus m is the number of pi groups which can be produced in this case. And the second part of this theorem is, the second statement of this theorem is a functional dimensional relationship, a functional dimensional relationship between n minus m pi groups, between n minus m pi groups such as pi 1, pi 2, pi 3, so on to pi n minus m is divided. The question arises, what are the necessary things which must be known to a people in order to decide or devise or decide functional dimensional relationship. So, in order to devise this functional relationship, you must have an idea about the scale variables. Again, the scale variables are those variables which cannot be grouped together to form a dimensionless group. So, in order to devise the functional relationship as discussed above, devise the functional as said above, the scale variables are chosen. So, the question is how this choice can be made. So, this choice can be made as number 1, a purely geometrical quantity is it not? A purely geometrical quantity may be length, okay. Second one is a purely quantity, but there is no involvement of force which may be velocity. A purely kinematic quantity is velocity, example is velocity. And the third one is a purely kinetic quantity such as density or dynamic quantity, a dynamic quantity density. Now, once you have selected the scale variables, now the pi groups for each pi groups for each n minus m variables left can be formed as, let us suppose I am considering the first group, that is pi, that will be variable, that let us suppose this is the first variable into scale variable 1 raised to the power a, scale variable 2 raised to the power b, scale variable 3 raised to the power c. Now, in principle, because pi is a dimensionless group, so it has no dimension. So, in principle, this should be taken as m raised to the power 0, l raised to the power 0, t raised to the power 0. That should be equal to the dimension here, the dimension of the variable into scale 1 mlt raised to the power this raised to the power b raised to the power c. Now, when you solve this, you will obtain an equation of this type: m raised to the power summation a, l raised to the power summation b, the power summation c, etc., equating summation a is equal to 0, summation b is equal to 0, summation c is equal to 0. You can easily obtain the value of a, b, c, d, and all those quantities can be determined. Now, once you determine the value for a, b, and c, you can easily frame the pi group for one of the rest variable first. Another variable should be taken to arrive at the other dimensionless group. Once all those dimensionless groups are framed, after that this dimensional relationship can be divided as function pi 1, pi 2, pi 3, pi n minus m, that should be equal to 0. This is the dimensionless relationship which can be arrived for a physical phenomena. Thank you.